All right, we're moving on to our next section. We're going to talk about solving quadratic equations by factoring. So this is our first of two algebraic methods for solving. All right, we already looked and we talked about how the x-intercepts are also called the roots, also called the zeros. Those are the solutions of quadratic functions. That's where they're equal to 0, right? That y value of 0. So to find them algebraically, we're going to do the same idea. We need to figure out when they're equal to 0. And through factoring, we've taken things that are expressed as a bunch of different sums, right? Sums or differences, and we express it as a product, right? Something times something else. The reason that's helpful to us is because the zero product property, let me zoom in a little bit, zero product property is this idea that if I am multiplying two things together, or any number of things together, and I'm saying that the answer is 0, the only way to get a product of 0 is for one of those two things to be 0. That's the benefit of multiplication over addition or subtraction. So when we factor, we're taking something like we see in example A, x squared plus 10x minus 24. We're taking something that has a bunch of separate terms. We don't have any rules about what adds up to 0, and we want to express it as multiplication instead. So we can use this idea of the zero product property by factoring to come up with those roots or those solutions. So we practiced our factoring already. Let's use it now. I have a trinomial here. The a value is 1. My b value is 10. My c value is negative 24. All right, and this is a really handy way to start off all of your solving, is to just list out A, B, and C, just to make sure you're on the right track. I can factor this using that product sum table. I need to make sure these things add to my B value and multiply to my C value. I don't worry about A when it's 1. And so we think, what are the factors of 24? Okay, I would suggest starting by thinking of the factors. 24 can be 12 times 2, it can be 6 times 4, it can be 8 times 3, right? And think about which of these are somehow going to get us to 10. And because I have a negative product, one has to be negative and one has to be positive. Well, 6 and 4 might get us to 10. 6 plus 4 is 10, but that's only works if they're both positive. 8 and 3 aren't going to work because it either gives us 11 or 5. So 12 and 2 are the numbers that work here. And because I'm adding to positive 10 and multiplying to negative 24, it's that 2 that has to be negative. So x plus 12, x minus 2 equals 0, right? I've factored just that trinomial on the left side. All I did, right, these are still equivalent, they're still the same polynomial, is I expressed it as a product, right? Bracket 1, x plus 12, times bracket 2, x minus 2. And so what the zero product property tells me, I'm going to cut this right down the middle. I'm going to look at each factor independently. Because either, if the answer is 0, either x plus 12 has a value of 0 overall, right? I'm multiplying by 0. Or x minus 2 equals 0. Oh, I've cut myself off a bit. There we go. So these are now linear equations, and I can solve linear equations as long as I isolate x. So if I subtract 12 from both sides here, this tells me that a value of negative 12 is a solution to my quadratic. And we already kind of knew this from talking about factored form. We know that those x-intercepts show up at that m and that n value, right? X minus m, x minus n. We know that the sign is opposite. So same thing for my second factor. Say maybe that this is the factor causing the 0. Well, if I add 2 to both sides to isolate x, x is 2. Right? This is my second solution. Because even if 2 doesn't make that first bracket 0, even if I plug 2 into the first bracket and I'm saying 2 plus 12, well, that's 14. Well, 14 times 0 is still 0. So I can plot these points. I can check this graphically, right? I could plug this into a graphing calculator, and let's take a look. We have x squared plus 10x minus 24 and there we go. We see one solution at positive 2. We can't see the other solution, but we already know that it's at negative 12. I'll expand my window a bit, and I'll throw my vertex in there just for the sake of seeing it. Still can't quite see it, but that's okay. We see our x-intercepts, right? We have these points here and a point over here, right? At positive 2 and at negative 12. So we could sketch that if we wanted. So a lot of this just comes down to, can you factor? Then we solve using those factors. Let's look at another set. Our a value is 1. Our b value is negative 3, and our c value is negative 18. So we're asking ourselves, what adds, keep mixing that up, to negative 3? What multiplies to negative 18? And again, I always start with the factors, right? There's a lot of ways to add to negative 3, but there's only so many ways to multiply to negative 18. So 18 is 9 times 2. That's not going to get us to a 3. 18 times 1, that one's not going to work for us. 6 times 3. Right. Well, again, because I have a negative product, if I make one of these terms negative and the other term positive, I satisfy both of these equations. So those are my factors, my second term of each factor, x minus 6, x plus 3. Right, and it's still equal to 0. All I did was factor the left side. I now say what x value solves each of these binomial factors. And we kind of know this already from factored form, but again, just for the sake of practice, set each of these equal to 0. This will be more helpful when we look at some other polynomials. And then solve each of those by isolating x. On the left side, x ends up being positive 6, and on the right side, x is negative 3. So on a graph, we'd see an x-intercept at negative 3. We'd see another x-intercept at positive 6. Trying another one. I have a greatest common factor to deal with first. I always want to deal with my greatest common factor first. So when I look at 2x squared plus 10x plus 4, I recognize first that there's a greatest common factor of 2. So I'm going to factor that 2 out front. Right? I'm dividing it out of each of the terms because it's in common. I'm going to make sure I leave it there. It's still a product. Right? It's not actually twice as small now. I have to keep it the same size. But it leaves me with an x squared from the first term, a 5x from the second term, a 2 from the last term, and it's still equal to 0. I don't have to worry about the right side changing. Now that I've factored that out, I'm worried about adding to the new b value, right, inside my trinomial. This is now the trinomial that I'm working with. And multiplying 2, positive 2. And so we look at this and we say, well, factors of 2, the only way I can get 2 is 2 times 1. But if I try 2 plus 1, no matter how many different signs, positives, negatives I try to throw in there, 2 and 1 are not going to get us to 5. So what this means is that this thing is not factorable. However, that doesn't necessarily mean that there's no solutions. If I graph this, so 2x squared plus 10x plus 4, and I throw this into a graph, right, I have 2 solutions. I have 2 x-intercepts. However, if I was to find those x-intercepts, if I choose some point to the left, I do some point to the right. Notice they're not nice numbers. And factoring only really works when we're getting integers or nicer fraction values. Right? This is likely an irrational number here. So what that means is that sometimes we can't solve by factoring. Right? It's a great method when values are factorable, but we don't always have the ability to get a solution from factoring. Right? So while there are solutions, and graphically will always tell us that, factoring sometimes doesn't work. All right, looking at this last one, x squared equals 16. We always want to start in standard form, right? Or at least equal to 0. So in this case, x squared equals 16. I don't want to deal with that. I want this to equal to 0 because I know I'm looking for those roots, those x-intercepts. So if I bring the 16 to the left side, x squared minus 16 equals 0. We can now recognize this as a difference of squares binomial, right? First term is a perfect square, second term is a perfect square, and there's subtraction in between. So we know that the first term of each binomial comes from the root of the first term, so square root of x squared is x. Second term, square root of 16 is 4, and I'm going to have one positive and one negative. I solve from here. This first bracket is going to give me a negative 4 when I solve. Second bracket gives me a positive 4. So I would see this as a nice symmetrical graph. 1 point at negative 4, 1 point at positive 4. My y-intercept is negative 16, so it's going to go way down somewhere like this. All right, so making sure you recognize all those types of factoring. So there's 2 more examples that I want you to try. Come back and we'll have those solved. Take a minute, pause, give these a try. All right, so let's take a minute to look at these 2. So for E, first step, I bring everything to one side, right? Like I said, I want to make this equal to 0. I can't divide by x's to try and solve or anything because I don't know if x might be 0. And I can't divide by zeros, so I have to factor. This one is a little different because all we have is a greatest common factor. X squared minus 5x, these both share an x. And so as soon as I break this into x times x minus 5, I don't have to go any further. I don't have to worry about that product sum because I already have 2 binomial factors, or 1 monomial factor. And while on the right-hand side, x minus 5 looks like we're used to, on the left-hand side, it's a little tricky because it's just a factor of x. But again, you're asking yourself, what makes this factor 0? And to make x 0, we just put in 0. So we have a solution at 0, right? The origin is going to be an x-intercept. And then we have another solution at x equals 5. We have 2 solutions here. F, on the other hand, not difference of squares because we don't see that subtraction. We could try a product sum table, but we're asking ourselves what multiplies to 2 and adds to 0. And that doesn't work out for us. And so this one's not factorable, but this time it also has no solution. So if we plug this into a graphing calculator, so we're going to do x squared plus 2. Right? Thinking about this, this tells us we have an x-intercept of, a y-intercept of positive 2, and this graph just continues up. There is no x-intercepts here. This graph does not cross the x-axis at all. So that's where we have no solutions. So be careful though, because like we saw in the example on the last page, right? Just because it's not factorable doesn't mean it doesn't have solutions. This graph still had 2 solutions. They just weren't nice numbers. So always verify. If you're unsure, if you're getting something that isn't factorable, verify through another method. Last thing we're going to look at is sometimes you have to simplify or rearrange first into standard form before you can factor. So it might involve expanding out some brackets that are already there and then combining like terms. Right. A, This almost looks like it's in factored form, but we actually have two separate terms. And I can only have terms inside my brackets, not outside, if I want to use that product sum shortcut, or sorry, that zero product property. So I'm going to expand first. I'm going to multiply x times this x plus 1. So x times x is x squared plus x minus 2. Oh, let me fix that. Equals 0. I only want it to be factored if it's fully factored. And this time we left the 2 outside. He was all by himself. That's not how I want to leave this. So now I could factor this thing. I could say what adds to 1, what multiplies to -2, right? A -1 and a +2 is going to work out here. And so I have my factors, which means I have my solutions. A +1, right? Flipping the signs, and a -2. Oops. Same thing with this next example. So I need to expand these brackets. I need to get this in standard form first because it's not fully factored. That x squared is kicking around out there. X squared plus 4x plus 4 equals 0. Now we can factor. We can say what adds to 4, what multiplies also to 4. We're going to get a 2 and a 2. We get our brackets, both positive. Everything here was positive. Because my factors are the same, I get the same result out of each. So I get a -2. I actually get a -2 twice. Right? So I technically only have one solution. Right? This graph looks like something that at -2, it just bounces. It hits the x-axis only one time. We'll quickly look at this last one. I'm expanding out my brackets to start. X squared plus 9 plus 6x equals 0. This looks a little funny, so what I'd recommend doing is rewriting it in that standard form order. Right, x squared first, then x term, then constant, right? We usually write polynomials in descending power. So I factor this one. See if you can get these factors. It's going to be an x plus 3 and an x plus 3. Because these are the same, I get a single solution of -3. So hopefully you are feeling good on solving by factoring. We'll finish off on our last topic, which is one more algebraic method, and can help us out with those situations where we can't factor but still have solutions.